I picked these questions because quite a number of you are rusty along uh, about the 68, 95, 99.7 rules. Okay, so let's start with looking at making sure you understand. Mean is here, one standard deviation away, and two standard deviation away. Okay, so it's a bell-shaped curve and it has to be symmetrical. Yep. Now, so you're given that the average, so the mean is 24,000 and standard deviation of 5,500. So on the mean, I'll use blue now, at the average at the 50% point is 24,000. One standard deviation away, 29,500, is basically 24,000 plus 5,500. You get this? So 24,000 minus 5,500, you get that. And then two standard deviation away, to get this value, you just go 24,000 minus two lots of 5,500. Same here. One is plus, one is minus. Plus if it's more than, minus if it's less than 50%. Now, question 8. What percentage of students will have a hex stat of less than 13,000? So, less than, it's this area, okay? Underneath the graph, on the left-hand side of the graph. So that's 2.5%, because it's two standard deviation. Okay, so 95 is left at the two ends. That's like 5% left, and you split 5% evenly into two halves, it's 2.5%. Part B, what percentage of students will have a hex stat between 29,500 and 35,000? 29,500, I'm switching to this graph. 29,500 is one standard deviation, 35,000 is two standard deviations. So we are looking for this little area here, the percentage of students. This is 97.5%, this is 84%. Okay, we calculate it based on this percentages. If you don't have the graph that the bell-shaped graph that we worked on earlier this year, make sure that you ask a classmate and get your notes ready. Okay, so then what percentage of students will have a hex stat between these two amounts? It will be 97.5 minus 84, because you're looking at the percentage between these two values, so it's 13.5%. Now part C, James has a hex stat that has a standardized score for hex stat of minus 1.73. They want to know the amount of his stats rounded to three significant figures. First thing you need to know, standardized score, this is the formula to use to calculate it. Actual take away actual data value, take away the average, the mean data value, then the whole lot is divided by the standard deviation value. Okay, so you're working backwards again. Minus 1.73 is this minus 1.73, and then the other side of the equation, basically you just substitute in, and because we are looking for actual, by the time you reach this particular line, you can use your CAS solve function. Okay, now three significant figures, we start calculating from the left hand side without any care about decimal place. Okay, so you start from the first non-zero value. In this case it's 1. Three significant figures means 1, 2, 3. I mean 3 is the second 4. Then you have to look at the 8 to decide whether it rounds up or round down. Obviously 8 is greater than 5, so the answer is rounded to 1,4,500. 3 significant figures. Question 5. A lot of you, there are two ways of doing it. So I want to talk about it, but you can see the explanation here. Yeah. At this point in time, accept both answers. The answer recommended by the exam writers is this one. The answer that we have been told to do, or we have learned to work out using the Cambridge textbook's instruction, is the one in red. Okay, I accept either answers, but to be safe, you should state it clearly that you're reshuffling or you're remapping the years into some index values. Okay, so 2001 is equals to 1, 2002 is equals to 2, and so on. Now, part B, it does not matter whether you use this formula or this formula. You will get the same result. Now, you have to round it to the nearest whole thousand. So this is the answer you would get if you use this formula. And then we were looking at rounding to the nearest thousand. The thousandth place is the 8. Now, a lot of you made mistakes. The important thing here is look at this. In the table, the response variable, number of female graduates, is in the thousands, okay? In the thousands. So all these figures, when you want to use it, you have to times it with 1,000, okay? So 1,478.49 is actually 1478490, okay, because you're multiplying with 1,000, which has 3 decimal places. Now that will bring 8 to be the whole thousands place, okay, the whole thousands place. So you look at the 4 is less than 5, so we cannot round up. 1478 followed by 3 zeros. Part C. Explain why this prediction may not be reliable. It's a 1-mark question. All you need is this word, extrapolation, because 2030 is outside our data range. We only collected data up to 2015, and now we want to predict 2030. It is a very, very unreliable prediction. Okay?